So we're talking about money and politics, and this is the one empirical paper I'm going to do. I'm not enamored with empirical papers, generally speaking, but I think it's useful to see them. And how many people are taking econometrics or have taken econometrics? Okay. And those of you who haven't probably will. So it's worth talking a little bit about this because it's an interesting paper from an econometrics point of view. Allows you to sort of see some stuff that's going on in that realm that's useful, and it's useful for us too because money and politics is a thing and we do wonder about it. So I'm going to be babying this thing all day, I can tell already. I'm very scared about knocking it out of kilter. Okay. So here we're looking at, does money affect political outcomes, right? And so we're really wondering, okay, let's see if this works. It's not going to work. So far, so good. So far, so good. Okay. So we're really wondering if we regressed votes. Well, let me see. V at time t, which is going to be vote share. So we're wondering what happens to your vote share as you spend more money, right? And so we could put on the other side, you have some vote share, say alpha plus beta 1 spending. And we could think that that's how things work, that when you increase your spending, you increase your vote share. And of course, we could put in your opponent's spending there that would decrease your vote share and so on. We could be careful about it. But at the moment, we're being sort of relaxed about it. Of course, in the end, we're going to have to be more careful. Okay. So we could do this. And if we're doing this, let me just talk about how econometrics works a little bit. So if we run this regression, we put in plus epsilon in there because there's always some randomness. Right? We say, we think this is the true way that the world works, that vote share is some constant amount plus something times your spending plus some random thing that happens to you. Okay? Now, clearly, we don't think this is the way the world works. We would want to put more stuff in here as well. But suppose we thought that this was the way the world works. Well, one way we can think about it is sort of in terms of Venn diagrams. So if I make a circle, is there going to be some way to make this black? Yes, black. And that represents the variation in V. Right, that is, we have, presumably, to run this regression, if we just had one guy, it wouldn't tell us much. What we would have to have is hundreds of guys, hundreds of elections that happened. Some of them had high spending, and some of them had low spending. Some of them had big vote shares, and some of them had low vote shares. Right? We put them all together, and we say, on average, how does the vote share depend on spending? And then the error term is just the fact that, capturing the fact that we don't know everything, and this regression line isn't going to capture everything that goes on. People are going to be off some line that we make, right? And so this error term is representing that. So if we think about just all these elections that we've got, and I make a circle that represents the variation in the vote share, right? This is, sometimes vote shares are high, sometimes vote shares are low, sometimes they're in between, and this is capturing all the variation. Okay. I can also make one that has the variation in spending. And when you run the regression, what we're really wondering is, does spending and vote share tend to move together? Right? Because if they were totally unrelated, if sometimes spending was high and vote share was low, sometimes spending was high and vote share was high, and they just were totally unrelated, then we would expect our beta here to come out to 0 or insignificantly different from 0 because they're just not related. Right? So we're thinking that they're related, and we're thinking that when candidates spend more, their vote share tends to go up. It's not going to be every time, but by and large, we're thinking when they spend more, their vote share goes up. And we're thinking that because we see them spending. Why are they spending? They must hope for something good to come out of that. Probably it's that their vote share is going up, right? So, So what we're really hoping when we do this regression, or thinking about, is this even going to be nice to me? Maybe my battery's dying. Bear with me just a second. Oh. Okay, we're going to try this one more time. One more time, and then I don't know what we'll do. What will we do? Something. We'll do something. Something will be done. Okay, try it from scratch. Ha! It works. It works. Okay. So what we're hoping is that our variation in V has some overlap with the variation in spending. Right? Because if it if it has overlap, that means they're moving together. Sometimes when spending goes up, vote share also goes up. And so we can say that there's a relationship between them. And this, we look at this overlap, that's going to be used to estimate beta, right? We have votes are equal to alpha plus beta 1 spending. So that overlap where they're moving together. And they might be moving together in a positive way. That is, when spending is high, vote share is high. They might be moving together in a negative way. When spending is high, vote share is low. But they're moving together. Now, they're not moving together the way I've drawn it perfectly, right? That is, there's variation in V that isn't related to the variation in beta. I'm sorry, variation in spending. Right? So sometimes votes go up just on their own, unrelated to spending. Other things might be going on. Because I haven't covered them. Like, only this, it's a Venn diagram. So this bit is unrelated, and this bit is related. Right? And so it's this portion that moves together with spending. And sometimes spending moves without affecting vote share because there's no overlap there as well. Right. All right, so this is your basic regression. That this is the information that's being used to estimate beta. Right? And now we're going to say, well, let me put in something else, because obviously votes don't just depend on spending. They depend on other things as well, right? And, oh yeah?
So V stands for value? What does it stand for?
V stands for vote share. Yeah, vote share in this story. Thanks. Okay. So it's not a particularly interesting situation. I mean, it's sort of the starting point. This is, you put one variable in your linear regression, and this is what you got. But there's not really much to do, right? So if these variations don't overlap at all, then beta will be 0. If they overlap completely, then we're going to have really high R squared. We're going to completely explain the vote share. But if they overlap a bit, we're going to have some information to estimate your beta, and we're going to have not everything explained, which is the typical situation, right? Okay. All right, so let's do a more interesting one. And here, I'm going to have a different story. I'm going to have votes is equal to alpha plus beta 1 spending plus beta 2 quality. And this is candidate quality. It's how good of a candidate it is. Now you can imagine that candidate quality is going to be something that's difficult to measure, because what is the quality of a human being? You know, it's not something that's particularly measurable. But let's pretend that this is how the real world works. Is that there is out there something that maybe we can't measure, but there is something about candidate quality, and that affects the amount of votes that you get. Okay? And really, if we think democracy is a thing, we're kind of thinking that that's a thing, right? If we thought that there was no differences in candidate quality, or they didn't matter, then what is the point of democracy anyway, right? So it's got to be, either quality is someone who's sort of good at whatever we want politicians to do, or quality is someone who's willing to pretend to be good at what we want politicians to do in order to be reelected. But certainly we want either the good people to be elected, or we want people to try to be good so that they'll be elected. Either way, we want quality to matter, otherwise we wouldn't bother with democracy in the first place, right? So let's pretend the world works that way. Okay? And let me do a series of examples in Venn diagrams for you. Okay, I'm going to start out. This is our vote share, variation in vote share. Right? And I'm going to draw two other variations. I'll do them in blue. I won't do them in blue. So here's spending. And here's quality. Right? In this case, there's no overlap with any of them. And life is easy, if sad, and none of these betas would come out significant because they don't move together. Quality doesn't move with vote share, spending doesn't move with vote share, and in fact, in this case, spending and quality don't move together either. So all the betas come out 0. Okay? Not particularly interesting, but this is potentially could happen. Right? And here we're pretending like we could somehow measure quality. Right? Okay. So we've got that, but we could also have sort of more interesting ones. We could have votes like this. And let me actually try to do blue, can I? And we could have spending like this and quality like this. Okay. And then this red area, well, let's say red area, okay. Colors are not happy with me today. Yeah, the red area. Hey, the red area. That red area would estimate beta 1. Right? That is where spending and vote shares move together. Right? And we would use that information to estimate beta 1. Maybe it's positive. Maybe they move in a positive direction. When spending goes up, vote share goes up. Maybe they move in a negative direction. When spending goes up, vote share goes down. But they move together, and we can use that information to estimate beta 1. And likewise, let's see, with the green, will the green work? Oh, green works. I'm so happy. That information there, where quality and vote share overlap, that's going to be used to estimate beta 2, right? Okay. This is simple. Everything is neat. Everything is clean. Everything is just like what we had when we did just one variable, just the spending. Okay? Nothing different. But it's never this way. It's never so easy. Here's what's more typical, what we would get. So I'll do a big one. Here we got vote share. Here, and then I'm going to have, in the blue, I will have this will be spending. And in the green, I will have quality. Okay. And now things are a bit messy. Right? If I take a look at, say, well, I'm wondering, for example, how does spending affect election outcomes. Right? Well, I can say, just sort of ignore the green for a minute. We can say, well, it's the overlap of vote share with spending, right? And so I certainly get all of, well, no, that's not nice. Colors will be the death of me. All of this area here, and kind of this triangle here, right? Except with that triangle, I am not sure whether the vote share changed because of spending or whether the vote share changed because of candidate quality, because there's this overlap. Right? So in fact, if I really want to know, does spending affect outcomes? Does spending affect vote share? I would want to not use this little triangle at all, right? Because that's overlap where they're moving together, but it's also moving together with quality. And so I don't know whether changes in vote share are due to the spending or whether they're due to the quality. There's no way to tell. Right? So what I should do is, if I put my little thing down here, we have V is equal to alpha plus beta 1 spending plus beta 2 quality plus epsilon. I should use this red area for beta 1. I should use this purple area for beta 2. And I should just throw out that information on the triangle. So this area here, I shouldn't use. Which is sad, like this is information, right? It clearly matters. That triangle clearly matters. It's moving with vote share. That is where quality and spending are moving with vote share. Clearly, either spending or quality or both are affecting vote share, but we don't know which one. And so if we want to know, like how much does spending affect vote share, we can't use that triangle because that triangle is just information that we could attribute to either one, right? And so we should really just get rid of that. Okay. And if you run a regression, it will do that automatically for you. Right? So it's not like you have to do anything to ignore that. It'll just automatically do that. And just to sort of make this more extreme, let me do an extreme version of this. Okay, so here's our vote share. And I am going to try to make an extreme version. You can imagine that my artistic skills are not great, but we have another, here we have that's variation in V. This is variation in spending. And now I'm going to make our variation in quality very similar to the variation in spending. That is, together they have a lot of movement with vote share, right? About half of vote share is taken up of these two things. But they move a lot together. Right? And so when we're estimating this thing, we really should only use this area here for beta 2 and this area here for beta 1. Right, we have V is equal to alpha plus beta 1 spending plus beta 2 quality plus epsilon. And we should throw out all the red. Because quality and spending are moving so closely together, there's very little independent movement where spending is moving but quality isn't, or quality is moving but spending isn't. And there's very little overlap with those with vote share. Yeah?
I didn't understand very well the main difference between spending and quality.
So, Yeah, so we can imagine that you and I are running for election. And you're a serious person who like really talks about the issues, and you're handsome and you talk well. And I'm a goofball who teaches economics. And so nobody thinks I'm a very good candidate. Like, people look at me and they say they don't want to vote for Ivan, right? So you're just a better candidate, right? And that's quality. But my dad's rich, and so I'm spending $200 million, right? So in that case, I have an advantage in spending. I'm spending a lot of money, but if people get to know you, they like you better because you're a higher quality candidate. People would think you're better at doing this job. Okay. Now, in this particular example, the quality and the spending are moving together a lot. There's a lot of overlap in the quality and the spending. So the guy who's a good candidate is also spending a lot, right? And they move together. And so it's very hard to tell whether he's getting a lot of vote share because he's spending a lot or because he's a good candidate. And we just can't disentangle those two. So what do we got? We have this tiny bit of information here that's used to estimate beta 2. It's just a tiny itty bitty piece of information, right? It barely moves independently of spending at all. And we've just got a tiny slice of information to estimate beta 1. Okay. This is called multicollinearity. And you will have seen it in your travels in econometrics, if you've traveled in econometrics, right? Multicollinearity. What does that mean? It means that we're going to estimate everything fine, right? Beta hat 1, beta hat 2 are unbiased. There's nothing wrong with those estimations at all. We're using the correct information. We just don't have very much information. So we have very high standard errors. It's just because we have so little information to base our estimate on. And so we have to say, look, we don't know very much about beta 2 because we only have this tiny sliver of information. Right? Do we have it? There we go. Okay. Computer hates me. That's cool. Everybody hates me. It's not just the computer. Yeah. Okay. Now it's here. Mysteries of life. Okay. So we have just that tiny sliver of information in order to estimate the beta, and so we don't estimate it very well. That is, we can't be sure whether it's very small or very large because we just have very little information that we used to find out what it is. Right? We just have this tiny little triangle here that we use to find out what beta 2 is. So we have to admit, like, we just don't know very much about beta 2 because we had very little information to estimate it with. Now, granted, there was huge overlap in quality and vote share, but we couldn't use most of it because there was also that same variation happened with spending as well. So we just don't know whether it's because of the spending or because of the quality. The only independent information we have about quality is this little itty-bitty triangle. Okay? Which means, like, it's perfectly good, we did everything right, we have unbiased estimates of our beta, but we just don't know what beta is very much because we have so little information that we had to estimate it. Okay. And the same thing, we have a little more for beta 1, but it's a tiny sliver, and so we don't estimate beta 1 very much. Okay? And so if you've taken econometrics, they've got the 5 assumptions of ordinary least squares, and one of them is that you don't have too much multicollinearity, right? That these things, there's not too much overlap in the variation between these things, because if there's overlap, we can't use that information, which means we're basing our results on very little information altogether. Okay. Okay, so that's the ideal world, right? I mean, if these things move together, obviously we'd prefer they didn't move together because then we'd get good estimates. But given that they are moving together, We would like to have information on candidate quality, we'd like to have information on spending, and then we would like to throw out where they're overlapping, where their variation is overlapping, because we can't tell whether that's due to spending or due to candidate quality. We would just like to use the independent variation. And yeah, we won't get very precise estimates, but we will get correct estimates, and we won't be teaching ourselves anything that's not true, right? Now, we want to learn as much as possible, but we don't want to learn anything that's not true, right? So, what can you do? Okay. Okay, this is just, okay. Everything unhappy with me. Okay, I think its little brain is full. I think there's too many programs running or something like that. Anyway, okay, so now we get to our real problem, which is we want to know how does spending affect vote shares, right? We really want to know this. And if spending was the only thing that affected vote shares, we would have some issues with measuring spending. But if we could measure spending, and we have elections so we can measure vote shares, then we could just run our regression and we would get some nice results, right? We would find out how it affects, at least to the amount of data that we have. The trouble we have is that we think what really affects vote shares, we think spending affects vote shares. And we think quality, candidate quality affects vote shares. And candidate quality is something that before we just say we throw it in and we see what happens. Except now we have a bigger problem in that we can't even measure candidate quality, right? So before, when I was doing the Venn diagrams, I was supposing that we could measure candidate quality. And we said that, well, we're going to have to throw out lots of this spending stuff, right? Lots of the variation we're going to have to throw out because we don't know whether it's due to candidate quality or due to spending. Okay? But now, let's pretend that we can't measure. But it's still there, right? When voters see the candidates, they can tell who's of high quality or not, at least in terms of who appeals to them or not. You may not agree with their decision, but voters are voters, they're the deciders. So they decide this guy's a higher quality, he's going to get more votes, right? But we as econometricians, as empirical people, apparently I'm an empirical people now, we as an empirical people, we can't see that. And so we leave it out of our regression. So now we have an omitted variable. The true world has candidate quality in it, so reality is vote share is equal to alpha plus beta 1 spending plus beta 2 quality plus epsilon. That's how the real world actually works in this little theory. But we estimate V is equal to alpha plus beta 1 spending plus epsilon. We leave out the quality, okay, even though we shouldn't. Now, if we were in this world, if this was the way the world worked, that vote share had its variation, spending had its variation, quality had its variation, but there was no overlap between quality and spending, and then we leave out quality, we've got no problem at all, right? Because this same information is still used to estimate beta 1. So if this was the world, leaving out our variable is not going to cause us any troubles. We'll still get an unbiased estimate of beta 1, everything will be fine because these variables don't interact. Right? They're not moving together, and so their variation doesn't overlap. We leave out 1, we've got no problem. Okay? Unfortunately, we don't really think that's likely to be the case. And in practical terms, it rarely is the case that it's literally that way. More, it tends to be like this or even like this. Right? We have some overlap. This one's easier to see, of course. There's some overlap between quality and spending, and there's some of this variation that we really shouldn't use. But now that we leave out quality, we are going to use it. So what's going to happen? So we have our variation in V. Variation in spending. Variation in quality. This is the reality. So ideally, once again, the colors are, there we go. We shouldn't use the red area, but in fact we will. Because we don't have the quality in our regression at all, and so we don't know anything about how much overlap there is. And so when we do our regression, we are going to use this entire area, including the bit we shouldn't use when we're running our regression. And so what we're going to get is we are going to get biased results. And low standard errors. Low standard errors because we're using more information than we would if we put quality in there. Right? We think we know a lot about how spending and vote shares move together, but in fact we're using information that we shouldn't be because we can't tell whether that's because of quality or spending, but we don't have quality in our regressions at all, so there's no way for us to know that, and so we use this information that we really shouldn't be. And if we have lots of multicollinearity, right, like we had, that one became a mess. Let's see if we can clean it up just a little bit. All right, that's better. Not great. If we have lots of multicollinearity between quality and spending, then we really should just be using that sliver, but in fact we're going to use the whole red area as well. Right? And that's going to be most of our information is stuff where we really don't know whether it's quality or spending, but we're going to attribute it all to spending. And so we're going to get wrong answers, and it's going to look like we've estimated them very precisely because we used lots of information, but those answers are in fact wrong. Okay? And this is something that plagues econometrics always, because this omitted variable problem, because you can omit a variable, and like if they're uncorrelated, it causes no problems at all. But if you're omitting a variable that's correlated with the stuff that you're putting in, you're going to get biased results, but it's going to look like you have really precise estimates. And so it's going to look like everything's wonderful, but actually you're learning things that aren't true. And you can imagine the world being the complicated place it is, everything's correlated with everything else, right? Everything is, no man is an island. We're living on an interconnected planet and whatnot. And so everything's connected to each other. So everything, more or less, is correlated with each other. And when you're running a regression, you can never put in everything that matters, right? You have to pick and choose. And because, first of all, you won't have data on everything that matters. And secondly, it will become too big. Your equation will become too big. And so you're going to be leaving stuff out. And you have to be careful to the best that you can not to be emitting something that's very highly correlated with the things that you're putting in, right? That something that matters, like candidate quality, because then you're going to have this big overlap, and you're going to be using that information even though you shouldn't be. And so you're going to get biased results, and it's going to look like you did a great job. Okay? And you're going to learn things that aren't true. Okay? People with me here? Yes. While we're here, just for people taking econometrics or maybe taking econometrics in the future, let me recommend a book. It's probably one N. I don't know, however many N's are in Kennedy. My president, I should know, but I don't. A Guide to Econometrics. It started out ages ago as a book just giving the intuition for econometrics. They've made it more into an econometrics textbook, so I highly recommend the book. But if you can get a first or second edition rather than an 8th edition, you're much better off. Like the earlier you go, the better, because it just has the guide and not so much of the... Here, in the newer editions, it's easy to not find the intuitive stuff, whereas before it was just the intuitive stuff, and so it was much easier to find it. But I highly recommend the book if you're taking econometrics or lost. Venn diagrams come from him. Okay, so let's go to our real problem. Our real problem is this, that we're leaving out, right? We have spending. We think affects votes, and quality. Also affects votes. That is one weird diagram. Both of them affect votes, and we will never have great information on candidate quality, because candidate quality is something that exists in sort of the mind of the electorate, right? They say, this guy has great hair. Maybe they think, therefore he's a high quality candidate, or this guy speaks really well, therefore he's a high quality candidate. It's not something that's likely to be measurable, because we can't even define it, but presumably voters know it when they see it. And it might not be the same thing every time, right? It could be that for lots of elections, people want someone with experience. And then so somebody who has lots of experience doing the job is seen as a high quality candidate. But at other times they might be thinking, all these guys are corrupt, and so we need to get new guys in there. And so experience might be a low quality candidate because you're seen as being part of the corrupt machine, right? And so it's not something that we're likely to ever have good data on, but it's something that's likely to be a real problem for us, right? Because if we think about where does spending come from, we think about that, it becomes, well, these guys are spending money because why? Well, clearly, they want to get elected, but also they've got money. People that don't have money can't spend money, and so somehow these guys got their hands on money. Now, some guys are just rich and they can spend their own money and there's no problem, but most of the politicians get money because people give them money, right? And so if we want to say, why do politicians spend money? We also have to ask, why do people give money to politicians? And there's a number of reasons why you might give money to politicians. You might give money to politicians because you think they would do a good job, and that's one way that you can show your support and help them get elected. Well, then you're giving them money because you think they're high quality, right? And so if we do this sort of thing again, it looks more like this. It's quality would lead directly to votes, but quality would also lead to donations, which would lead to spending, and presumably spending leads to votes as well, right? And so the quality in this story is the driver of both votes and spending, which leads to votes. which means that quality and spending are likely to be very closely related. They're likely to have a lot of overlap in that Venn diagram. Right? We're very likely to have multicollinearity. It's much more likely to, we can go back, be this sort of situation where there's a big overlap rather than a situation with no overlap. This is very unlikely because quality causes spending, right? And so when quality is high, spending will also be high. They will tend to move together. And so this thinking of them as completely separate issues is probably wrong, right? And we can also think of other reasons why people might give money to politicians. They might give money to politicians because they want the politician to owe them. Right? I'll give you $1 million, and next year on my tax thing, maybe you can help me out. Right? I'll give you a bunch of money, and then you can give Liffey Valley a tax break so that it can compete with Blanchardstown, the reason they gave money to Bernie Ahern. So this is a thing that can happen too, right? But again, this is only useful to give the guy money if you think he's going to be elected, right? And so if he's a high-quality candidate, he's more likely to be elected, and so he's more worth bribing. Whereas if he's a low-quality candidate, he's unlikely to be elected, and so why even bother to try to bribe him, right? And so you're only going to bribe the people, or attempt to bribe the people, that are likely to be elected. These are going to be the high-quality candidates as well. So you get the same thing, that quality leads to donations, which leads to spending, which leads possibly to votes. And so what we're trying to estimate here is this bit. How big is that bit there? But it's really hard to take that apart from quality, and we're very likely to have this multicollinearity problem. So if we just run a regression with spending in it, it's likely to look really good because they're using a lot more data than we're supposed to, but it's likely to be biased. So we're likely to be very confident that we learned something, but that something will be wrong. Okay, so we're going to learn wrong things. So clearly that's a problem, right? Now, everybody was aware, we're going to be looking at Levitt's paper, which is one particular way to solve this problem, or to attempt to solve this problem. But the first thing to notice is that we really have a problem, that we have this multicollinearity problem, that these things are correlated, that it's going to give us biased results that are going to look really good, right? And then we're going to talk a little bit about how people try to address that problem. But when you're doing your own regressions, which many of you will, you need to be thinking in these terms, like what kinds of things can be causing problems with my regression. And they give you the 5 assumptions of OLS, and you should go through each of those assumptions and say, to what extent is that not true in my regression? And the hint is, they're all wrong in your regression. Your regression is always wrong because the world is never as perfect as our regression world. And your job is to say, well, to what extent is it wrong? What can I do to fix that to the best of my ability? And how do I interpret my results knowing that my regression is imperfect? Right? If you start arguing in theses or whatever, if you start arguing that, no, my regression is perfect, everyone's going to laugh you out of the room. Like, they're never perfect. It's always imperfect. You're always muddling through the best you can. Data is always messy, and you're doing the best you can. What you want to do is have like a scientific attitude about it. Okay, to what extent is it problematic? What are the nature of the problems that I've got? Is there anything I can do to fix those problems? Given that I can't totally fix all the problems, how should I interpret my results so that I don't learn anything that isn't true? Right? And we're going to talk about the Levitt paper and his solution to this, but the guys before, they were well aware that this was a problem, that this candidate quality thing was a real problem, but they had to do the best they can. Right? It's data. You have the data you have. You will never have perfect information on candidate quality. But we do want to know how spending affects votes, because that's a major public policy issue. Should we control the spending? Shouldn't we control the spending? Does democracy get corrupted, right? And so they muddle through the best they can. And sort of the main way they did that is say, okay, we don't have perfect information about candidate quality. We don't even have very good information about candidate quality. But let's do our best to come up with what we can. right? And so they would use things like, how did the guy do on the last election? Right? If the last election he was very, everybody loved him, maybe he's just a lovable guy, right? Or how many years of experience does he have? Has he been through lots of elections? Does he have, lots of experience doing this kind of job? That kind of thing. Right? Now, we know that that's not everything that voters look for, but presumably, possibly, maybe, that's some of the things that voters looked for. So they looked for everything measurable that they could come up with that might be related to candidate quality, and they would put that in the regression. Okay? And that whittled away at that overlap area that you weren't supposed to use. Right? And that's good. Right? It lowers the bias, makes things better. Okay. How do we do? So. Okay, I'll leave the what to do about it, what Levitt says to do about it next time. His trick is going to be to throw out lots of the data. That instead of using all the data, he's going to throw out most of the data, like 95, 98% of the data. He's just going to throw it out, just toss it, and use only the data where he can say something useful about candidate quality. Okay, I'll let you go, and I'll see you next time.